Alright, for the next part here, we're starting with number 9 next here. We're going to solve the following triangle ABC for the missing angles and sides. So here, first of all, we're going to want to sketch out some sort of triangle here. And in this case here, we don't know if it's the right triangle or not because we don't have any 90-degree angles. So let's say, for instance, here that we labeled this angle down here as angle A. This one up here is angle B. So we use the capital letters here, like I put in the note, capital letters for the angles. And then the lowercase of those to label the sides. So then we have lowercase a here, lowercase b across from angle B, lowercase c across from angle C. So here, angle C we have is 50 degrees, so that would be this angle down here. It's 50 degrees. And then we have A is 3.2 inches. And then we have B over here is 1.3 inches. And then we have to go through and figure out what our other side here, our side C is, and also our angles A and B that are missing. But here we cannot just use our sine, cosine, and tangent by themselves like we did before, because we can only use those whenever we're dealing with right triangles. So like number 8 that we did in the last video, we could use the sine, cosine, and tangent stuff because we are dealing with a right triangle. Here we do not have a right triangle, so in this case we have to use either law of sines or law of cosines. But in this case, if you look here, we have an angle, but we don't know the side opposite of it. And then for our other two sides, we also don't know the angles opposite of those two sides. So what that means in this case is that we're going to have to use the law of cosines here. So let's jot that down first of all. In this case here, we'll use the law of cosines. So to set up for the law of cosines, you got the side opposite of your angle, so in this case it's c squared. So it starts out looking kind of like the Pythagorean theorem, because then over here we have a squared plus b squared, because those are the other two sides, but then we also have that minus 2 times a times b times the cosine of your angle c is the formula. Here we just start off what we get whenever you do 2 times our other two sides times cosine of our angle. So here in this case, we're trying to figure out what our side C is, first of all using this formula. So then we'd plug in our 3.2 squared for our a squared part. And then we'd have plus, and then we have the 1.3 squared. Minus 2 times, and then we have our a, which once again was 3.2, times b, which is 1.3, times cosine of our angle c, which is 50 degrees. Remember, all of these in this last part here are all being multiplied together there. So once you get that set up, it's a matter of just going through and plugging in the values that you have there into your calculator to get to the answer. Once again, depending on your calculator will depend on exactly how you enter those in. So you do want to make sure that you're careful whenever you're calculating those. So here if we do 3.2 squared, and some of you may have to split this into multiple steps, and others of you may be able to put it all in at once. Then you do that 3.2 squared plus the 1.3 squared minus 2 times the 3.2 times the 1.3, and then also times that cosine of 50 degrees. So once again, make sure your mode is in terms of degrees. So here for your c squared, to get that entered in, you should get approximately 6.58. again, yours may be slightly different if you rounded some of these along the way. Keep in mind on the homework, make sure you're keeping all of the digits until your final answer there, so that way you're rounding it the same way as what they do in the homework. On a quiz and test, make sure you're showing your work like normal. And then remember, if you have something squared, to undo that, you do the square root. So here then for your C, you then have to do the square root of that answer that we just got, the 6.58. So here if we do the square root of 6.58, here we get approximately 2, let me write that a little bit better here, about 2.57 approximately. And then here, remember that was one of our sides, so that would be in terms of inches. So just like before, make sure that you're labeling what your values are in terms of your units for your sides or degrees for your angles. So that would be one way to start. And then once we have that set up, once we get that side, we can then go ahead and use our law of sines next to figure out our two angles, because now we have an angle and an opposite side. So now from here, we can use law of sines, since that one is normally a little bit easier to solve for the angles. So we can use that to figure out one of our other angles, and then once we have that, remember you just need all your angles to add up to 180 degrees. So here, for this next part here, for instance, we could write it as 3.2, or actually let's write out the formula here first as a reminder. You'd have your side A over sine of angle A is equal to side B over sine of angle B, which is also equal to side C over sine of angle C. So remember, the lowercase letters are the sides opposite of those angles. And of course, to solve these, you're only going to use two angles and two sides. So we can't solve it when we have three different ones, so you want to set that up with just two at a time. So here, for instance, if we want to figure out angle A, we could set it up as 3.2, so side A, over sine of angle A is equal to, and then the side that we already know, which we just solved for, was 2.57 for side C. But if we're using side C, then we have to do that as sine of angle C, which is 50 degrees. And then, like before, we'd want to then go through and cross multiply next. So here we'd multiply those two and multiply those two. Here it'll be once again a little bit trickier because we're solving for an angle rather than a side. But you're still going to enter into your calculator the 3.2 times sine of 50 degrees here. So here, once again, make sure that you're writing out either all of that still, or you want to make sure to write out all the digits for your work here. So you're really doing 3.2 times sine of 50. Just going to keep writing that out for now until we get to the last step to keep it exact here. And then we have the 2.57 times sine of angle A. And then to try and get the sine of A part by itself, we're going to want to divide both sides by 2.57 next. Once again, depending on your calculator, you may have to do some of these steps separately here. And then to get rid of that sine in front of the A, we're then going to have to do the inverse sine of both sides to get rid of the sine function. So remember, you can't just divide by a sine. You have to do the inverse sine then of this entire answer. So it may be helpful to get the answer here first for that 3.2 times sine of 50 divided by 2.57, and then do inverse sine of that. So that way then you're less likely to make mistakes getting that entered. Because then that'll give you your angle A here. And remember here, this is in terms of degrees since we're solving for an angle. So here, I'm going to enter this in. Get inverse sine of 3.2 times our sine of 50 degrees divided by the 2.57. So it looks like here we get about 72.52 degrees. So once again, on a quiz or test, if you're getting slightly different answers, it's alright. You just want to make sure that you're showing all of your work. And on the homework, once again, yours might be slightly different if you are rounding along the way. So make sure to keep that in mind as you're going through the problems. If it's counting yours as wrong, it might just be because you rounded differently there. You may want to go through and write out all your digits there, so that way you're getting the same answers. And then remember, once you have your angle A and angle C, so now we know angle A here also, which was about 72.52. Try and squeeze that in here, about 72.52. So then we'd want to add together those, or just subtract them both from 180, because remember all three angles have to add up to a total of 180 degrees. So to figure out angle C here, so let's write it out this way. Our angle C, you can find that by doing 180 minus the 50 that we already had for angle. Whoops, I wrote down the wrong angle there. Angle B is what we're solving for. We already had angle C. There we go. Angle B, the top angle, is what we're solving for. So we do 180 minus angle C, which we already knew was 50, minus angle A that we just solved for, the 72.52. And then you want to plug that in, see what you get here. So once again, you're doing 180 minus 50 minus 72.52. So it looks like here we get about 57.48 here. And once again, this was an angle, so that would be in terms of degrees once again. So we'll go ahead and box in what our three answers were. We had our side C, which was 2.57 inches, angle A, which was about 72.52 degrees, and then we had angle B, that top angle, which was 57.48. Just like with a lot of math, there are definitely multiple ways to get to this answer. This is just one way of getting there. So make sure if you're having questions on any of this, make sure to ask, just like normal. And then the other one I want to go through in this video is number 10. This one's a lot shorter than number 9 was. Because here, we're actually dealing with a right triangle again. This is a right angle like it appears to be. And we're finding the angle of elevation, which is just that angle theta that we have labeled in the picture. So to figure out what that angle is, first of all, we're going to want to label our sides here. So here, if we have that as our figure, then we have this would be our opposite side of that angle. This side is adjacent to that angle. And then this side is the hypotenuse, since it's opposite of your right angle. So here, if we're trying to figure out which trig function to use here, we want to use the one that has the adjacent and hypotenuse. So if we write out our acronym again, our SOHCAHTOA, you'll notice the one that had adjacent and hypotenuse was this part here, which means we want to use cosine. So in this case, we'd set it up as cosine of your angle theta is equal to your adjacent, which was 20, over the hypotenuse, which was 35. And then just like whenever we were solving for an angle in the last problem, whenever we solved for angle A, how we had to use the inverse sine to undo the sine function, here we're going to have to use inverse cosine to undo the cosine function, since those are opposites of each other. Just like multiplication and division are opposites, cosine and the inverse cosine are opposites. So to figure out our angle theta here, we're then going to have to enter into our calculators the inverse cosine of 20 divided by 35. So here for your theta value, you should get approximately 55.15 degrees. And that would be for your angle of elevation there. So you do want to make sure, like normal, that you know how to enter those into your calculators, since it's a little bit different depending on what calculator you have for each of these. If you have questions on it, let me know.